Ladies and gentlemen, those will find their way to YouTube, and you'd be surprised how many people use these things. Okay, great. I much appreciate my YouTube, the YouTube audience out there. And I want to thank Joe and the Sachs Institute for saying that I can share these videos on YouTube. When I teach a group like this, it's no exaggeration to say that there's probably hundreds of additional ears that are going to be seeing this and hearing this because of the generosity. And it's kind of all of you to be able to accommodate that. Okay, so let's go put in place some basic reports on this population. To do this, right. I'm gonna, nice. Okay, I'm gonna request that we do, we put in place a little bit of aesthetic brush up on this. So I want to put in place a function that returns, is someone obese or not? It's going to be called isObese, okay? How would I do that? Where do I go to add a function to my model? Okay, to agent, that's exactly right. It's to agent. To agent we will go. Okay, here we go. And here's a function, and we're going to drag this in, and it's going to be called isObese. That's the kind of common convention in Java to call these things to say yes or no. In other words, Boolean, true or false. Call it is something like, is overweight or is diabetic, that sort of thing. Or has in utero exposure, what have you. So is overweight. Now this functions are your friend, folks. Functions are your friend. And they're going to simplify your life. I know it's going to seem weird. I'm asking you to create this function, but it's going to make some things beautiful later. Okay. Yes. So this is a function, and you're going to tell me it's going to return true or false. So what does it do? Is it just an action, or does it return a value? It returns a value. Good. It returns what sort of value? Is it a double, like 35.263? It's a Boolean. It's a Boolean value. Okay. So you folks have seen this before. How do I know if someone's obese? Well, okay, I'm talking in the model. Sorry? Yes, exactly. So who do I ask if the state, which state is current? Who do I ask? Is the certain state active? Do I ask this variable? Do I ask this parameter? What do I ask if its state is currently active? The state chart. The state chart containing that state. So I would say return, the value I'll return is wait state chart, wait state chart, control space, dot, is state active, and then what state do I ask about? Obese. Okay, now, that may not seem to you beautiful, but it opens up great opportunities for beauty. Okay, but I'm going to add one more function. Now, I ask you to humor me. Okay, the other one I'm going to do is diabetic. Okay, and I want you to tell me what to do for that. This is going to be your assignment here. So I'm going to call this one is diabetic. Is diabetic, okay? Diabetic. And you're going to tell me, what do I fill in here? You bet. Is state active? Sorry, this one here. There we go. Wait state chart dot is state active obese.
What happens to the false? Where did that go?
Oh, this is state active itself returns true or false.
Okay, so where's the false? Where should you be to do that one? You're in is OB, right?
Yeah.
Instead of the function was meant to be false.
So this function returns a value that's either true or false.
Yeah. And where's that from?
And that value that it returns is given by this. So it just kind of delegates the job to this thing. It returns a value that's the same as the value returned by this guy. Whatever value is returned by this guy, it's going to return. What value is returned by this guy? It's asking the weight state chart, hey, is this certain state active? And that's going to return true or false. And that's what this function is going to return. So if this thing is true, that's an indication that the obese state is active, and therefore is obese is going to return true. If this thing is false, this state is not active, then it's an indication that is obese is false, so it's going to return false. Does that?
Well, what happened? You had before, you had false. Where did that go? You had false.
Yeah. Oh, you're saying, okay, I think I know what you mean. I think you're saying that when I first created this, let's go create this function. Watch this. I'm going to go create a function. Is diabetic, like that, right? And I'm going to say it returns a value. And you'll notice when it says double, it returns 0 by default. All it's doing is it's filling in a sort of placeholder value. So if I said return a string or return some dummy string, if I said Boolean or return false, all I did is I got rid of this. And I said, because it has no meaning to it, return false. It's always saying false. So what I did is I typed that other thing instead. For the is obese, I typed out this thing. And I had it return that value. Does that make sense? So this is the value it's going to return. If it returned false all the time, that would not be doing its job. It would be saying, is this person is an obese person, and it says, are they obese? And it, no. Is this one obese? No. Everyone is no. And instead, there needs to be some logic. We need to ask the weight state chart, hey, is this state active? Are they currently obese? And if so, we're going to say, yeah, it is true that they are obese. Otherwise, we're going to say false. Does that make sense? Okay. So you're going to tell me, and the clock is ticking, what is diabetic going to do by the same token? We're going to use the diabetes state chart. We're not going to ask weight state. It doesn't know anything about whether the diabetes state is active. We're going to ask diabetes state chart, and to do that, we'll say diabetes state chart dot. This is kind of directing a question at it. Okay, and then what do we type? Is state active? Beautiful. And then what do we ask? Which state? Diabetic. Yeah, exactly. Okay. We've just completed 2 functions. Now you may ask, why are we creating these dumb functions? I mean, all it is, we could just type this, but by using these functions, we'll simplify things quite a bit. Okay, so first of all, remember this cumulative obesity years? Do you remember that function we created earlier? Let's go clean her up. Go to cumulative obesity years. Do you recognize what I'm doing here? This weight state chart is state active. Does that look familiar? What should I be instead just asking? Am I obese, right? I just have to ask, am I obese? I mean, you shouldn't have to look at this whole thing unless you absolutely have to. So rather than forcing you to look at that, I'm just going to say, and to figure out what's meant by that, you're going to have to parse it out. All you say is, if I'm obese, then do this, otherwise do that. So this is useful already, but where it's really going to shine, like our fair city, is in computing statistics. Okay? Great. So I'm going to build this, make sure things are hunky-dory. Do you say hunky-dory here? Okay, good, yeah. Well, I think it's a difference in generations, perhaps. My generation, you say hornswaggled? No? Okay. Okay, well, we'll leave this for later. Great. Okay, terrific. So let's go up to main, and we're going to go compute statistics. Okay. So we're going to go and we're going to specify statistics for the population. So go click on the population there. And you'll notice when you click on the population in main that there's an area called statistics. Do you see that? Do you see it says statistics here? If you go to population in main, double click on main, go to population, it'll say statistics. Do you see it? Okay. So I'm going to open up statistics, and you notice it says no data items yet. I'm going to define a data item, and it's going to be called prevalent diabetes case count. How's that? Is that okay? Okay. And it's going to count. Now, in general, those little light bulbs are your friend. There was actually a light bulb Dylan pointed out. I could have told you about. There was a light bulb. Remember when I put that self in earlier? Remember that self? It suggested that to us if we had only gone and looked at the light bulb. Dylan, sector 1. So this light bulb is telling us something, and you'll notice what it's telling us. Pay attention to it. It's giving you useful information. It says use item, the embedded object. Now that sounds almost mysterious. But what it means is this statistic is going to go through each person in the population, person number 0, person number 1, person number 2, and it's going to be calling each one in turn item. And we're saying we want to count the number that match some condition. So all we have to do is write a condition that involves this term item, which is going to refer to the current person. Say, okay, does item of this characteristic or of that characteristic, that will determine the condition. It's going to count up the number for which that's true, okay, for which that condition is true. So if I want to count the number of diabetics, what would I have to do? Item dot what? Is diabetic. Yeah, is diabetic. Boom, there, filled it out for me. Okay, now suppose I want to do I want to count the number of obese people. So I want to do prevalent obese case count. I want to count the number of obese cases. What would I do there? Item dot is obese. Okay, good. Suppose now I want to do a sort of total up. This is going to be a different one. An average over the population of the number of cumulative person years that each population member has spent obese. So this is going to be called something like mean years obese or something like that. An average over the population. How would I do that? What would I take the average of? Yeah. Over, yes, item dot cumulative obesity years, right? Is that okay? Are people okay with that? So we've defined in short order with an economy of beauty. We've defined 3 different statistics. We count up the number of diabetic individuals, number of obese individuals, and the number of cumulative obesity years. Now, ladies and gentlemen, you could argue, rightly so, that instead of saying is diabetic, we could have put on this long thing. We could have said item dot weight state chart dot is state active. But in my mind, that would have been crufty. It would have been obscure. It would have been painful for you to look at. This at least is more transparent, is it not? Item dot is diabetic. It says we're counting up the number of people that qualify by being diabetic, number of people that qualify by being obese. For each person, the number of cumulative obesity years. So it gives it a nice, clear feel to it. Okay, so let's build early, build often. Are you comfortable with that? And now let us, ladies and gentlemen, let's run them off. Okay, and we're going to run it, and let's go. We're going to learn how to link these up in a final crescendo, the final movement of today's symphony. We're going to link these up to graphs. But for the moment, let's just click on this population here, and what you'll see is statistics being computed dynamically. Do you see this? Mean years obese. It's rising. Prevalent diabetes case count, 2022, sort of oscillating around the 20s. Prevalent obesity case count, that's interesting, 5.4. It's actually reflecting the sort of the live statistics in this population. But you'll notice that the mean years obese is being totaled up because people are coming back to an obese state on an occasional basis. Realistically, we should have made that obese state more sticky, so it's less likely you leave it. I think in this case we said people leave it within 2 years on average, with a hazard rate of 0.5 rather, which is too optimistic. Okay, so the final thing we're going to do here, and then I'm going to have to leave the room and leave you in peace, is we're just going to add a graph or two. Okay, so ladies and gentlemen, are you ready? Are you ready for the crescendo? Okay, thank you. Not quite a Greek chorus, but encouraging nonetheless. So let's click on main here, and let's go over to the palette. And from the palette, we're going to go to an area that's been off limits, an area that we've never yet touched, an area that will be very powerful for your day-to-day modeling work. And that's this area, this analysis zone. And this is all sorts of useful little widgets that you saw demonstrated in that original model with which you engaged, that model of gestational diabetes. But for now, we're going to confine ourselves to simple tasks. I'd like you to grab out a time plot, and I'd like you to scroll up here on the right-hand side in main, double-click on main, scroll up on the right-hand side, and I'd like you to drag over a time plot here, okay? This time plot. And this time plot, if we go click on it, we're going to say plot prevalent cases, okay? Plot prevalent cases. And the data that will be plotted is the key thing that we're going to specify here. And this, too, will be reflective of AnyLogic's economy of specification of statistics. So what did we do? We went over to the palette. We availed ourselves of the analysis tool, the analysis component of the palette. From that, we dragged in a time plot to the top of this main, okay? And then we need to just add these two items on. And I'm going to plot so diabetes cases and obesity cases. And all we need to do is to fill in population dot, and we say prevalent diabetes case count for this one. And for this lower one, we say population dot prevalent obesity case count. How did AnyLogic know about prevalent cases of diabetes and of obesity? From whence did this term come? from ourselves, ladies and gentlemen, no less. You just entered this. Where did you enter this? Not 5 minutes ago. This is no less than a statistic that you entered. Remember, we entered those statistics? So all we have to do is put that there, and we're off to the races. And I'm off to the to the director. That's right. So here we go, and here we see our population here. But oh gosh, here we have recorded the number here of diabetes, obesity cases, and then I think diabetes cases are, oh gosh, okay. I'd have to look with diabetes cases. There should be, oh, maybe they, okay. I'd have to look. There should be some there, but I'll put that back up, and then I've got a race. Okay, so let's go put this back up, and there we go. Prevalent obesity case count, prevalent diabetes case count. Maybe the diabetes ones are small enough